Okay, so let's try to make, let's say R is X minus Y. It's kind of hard to try to make this table without rewriting both of those tables, so I think I'm going to add both of those tables below. Okay, so once you finish copying that information down and these tables down, this we called ECC North, ECC South. Let's see what would happen if we calculated, and we assume that these are two independent events, R, which is X minus Y. So think about what the chart would look like for R and its probability. And before we were adding them, now we're subtracting them. So when I think about this, I'm trying to think, I want to kind of do this in as good of order as I possibly can. So you're going to be subtracting each one of these, like 12 and 12 will make 0. 13 minus 12 will make 1. 14 minus 12 will make 2. Okay, so I'm trying to start at the smallest number. Let's see what happens when we do 12 and take away 15. We'll make negative 3. Okay, 12 take away 18 will actually make negative 6. And I think that might be the smallest number that we're going to be starting with. Negative 6 is 12 take away 18. 13 take away 18 would be negative 5. Negative 4, negative 3, negative 2, negative 1. 0 is going to be made by 18 minus 18. Then I'm going to work at 12 take away 15 is negative 3. I already have that. 13, 14, 15 take away 15 is 0. 16 take away 15 is 1. 17 take away 15 is 2. And 18 take away 15 is 3. Then I go through with the 12. 12 take away 12 is 0. 13 take away 12 is 1. 14 take away 12 is 2. 3. 16 take away 12 is 4. 17 is 5. So we need to go up to positive 6 for this one. And I don't always organize them like that, but it's pretty much easier if you do. Keep in mind the probability is going to be the same thing. To find negative 6, the only way to get that would have been the 12 minus 18. So that's 0.25 times 0.3. So I'm getting 0.075 for that one. 13 take away 18 made negative 5, so I'm using the 0.1 times 0.3, which is going to be 0.03. To make negative 4 is 14 take away 18, and that would be 0.05 times 0.3, 0.015. Because I organized it like this, it might actually work out where all the probabilities are going to be the same as in the plus chart. Negative 3, I think, was made two ways, right? By 15 take away 18, so that's 0.3 times 0.3, 0.09, and also by negative 3, right? 12 take away 15, 0.25 times 0.4 is 0.1, and you combine them to make 0.19. So take a minute and try to calculate all the rest of the probabilities. Just like on the last page, let's find the mean of R, which would be where you take every R value and multiply it by its P value and sum them all up. So it should be negative 6 times 0.075 plus negative 5 times 0.03 plus negative 4 times 0.015 -3 times 0.19, all the way down to 6 times 0.045. Any ideas? Hopefully you're getting -0.35. Quick shortcut to how to get there: if you would have taken the mean of x and take away the mean of y, get there the same exact way. 14.65 take away 15 is -0.35. And that works every time. So from the first one, if we added them, we added them. If we subtract them to find the combined probability chart, you subtract them to find the mean. Now the variance. I kept the variance from the last page up here. So let's talk about what the variance of R would be. That's where you're going to sum up the value of R, and you're going to take away the mean of R, square it, and then multiply it by its probability. And you sum all those up. So what it would look like would be -6 take away -0.35, square it, and times it by 0.075. Add it to -5, take away -0.35 squared, and times it by 0.03. Add it to, all the way through till you get to 6 minus 0.35. So these all end up being pluses in the middle here when you multiply them. Standard deviation. What ends up happening for the standard deviation is 9.63 when you calculate it. If you remember from the one we just did, standard deviation was also 9.63. If you take the standard deviation for the x and the standard deviation for the y, we still want to add them. 4.23 and 5.4. That works. So in summary, standard deviation stays plus throughout it. The deviation is still the same throughout. Remember when we were looking at those back for chapter 2, what happens when you add and subtract numbers and multiply and divide and the effects of them. Addition and subtraction did not change the standard deviation. So when you add or subtract, your standard deviation is going to remain the same throughout it. So some formulas to summarize are, like, if you're finding the mean of x plus y, and this is from yesterday's or the video before this, you could take the mean of x and add to it the mean of y. From today, if you're finding the mean of x minus y, you could take the mean of x and take away the mean of y. For this variance, to be able to calculate the standard deviation, we would actually just be looking at the variance first. When it's x plus y, you take the x and you'd add it to the y. When it's x minus y, you still do the same thing. You still add them together. So this is your mean rules, and these are your variance rules that will help you then go and do the standard deviation.